Today we're going to be working on section 4.6, rational functions. What is a rational function? We've already learned about what a polynomial is. A rational function is in the form of a fraction where both the functions g and h are polynomial functions. The only thing that we have to be concerned about is that the denominator does not equal 0 and the degree of the denominator is greater than 0, which means we don't want a constant. If we have a constant in the denominator, we don't consider it a rational function. We can rewrite it into different fractions. For example, if I had x squared plus 2x plus 7 divided by something that's a degree of 0, let's say 2, I can separate this fraction into 3 terms, which is 1/2 x squared, plus 2x over 2, which is x, plus 7/2. And now that's a polynomial. If it has a constant, we don't consider it a rational function. The domain of f, or of the function, is all real numbers except for where the denominator is equal to 0. The y-intercept is x equals 0. Whenever we want the y-intercept, we take x equals 0. And whenever we want to find the x-intercepts, all we need to do is look at the numerator, because 0 divided by anything, x can't be equal to 0. Since that can equal 0, all I really need to worry about is my numerator. First example, determine the domain of f. Well, the domain is anything that x can be. The first thing we really need to do is factor. We have x minus 4, there's nothing to factor there, but we can factor this denominator into x plus 3 times x minus 2. Now it's factored. Since it's all factored, this denominator, x plus 3 times x minus 2, cannot equal 0. That means x cannot equal negative 3, and x cannot equal positive 2. Those are very important. If it's either equal to negative 3 or positive 2, I get a 0 in my denominator. If this is my domain, let's see how to write it in interval notation. Here's 2, and here's negative 3. And I know I can't equal negative 3, and I know I can't equal 2, but I can equal everything else. Again, whenever I want to write something in interval notation, I start at my smallest number. I'm starting from this side and going this way. My smallest value is negative infinity, and it goes all the way up to negative 3, but not including negative 3 because I have that open circle. And then it begins again at negative 3, but again not including negative 3, and it goes all the way to 2. And then that takes care of my middle part, but I still have the part that's greater than 2. I union that with 2 to infinity. And that basically says it's from negative infinity to positive infinity, except I'm leaving out negative 3 and 2. Determine the y-intercept. Well, the y-intercept is x equals 0. If we plug in f of 0 is equal to 0 minus 4 over 0 plus 0 minus 6. That equals 4/6 or 2/3. Now I know my y-intercept is 0, 2/3. And now my x-intercept, remember we said as long as the numerator equals 0, we don't have to worry about the denominator. So x minus 4 has to equal 0. If x minus 4 equals 0, then I have 0 divided by some number. It's still equal to 0 because we want y equal 0. X minus 4 is equal to 0, so that makes x equal to 4, and that is my x-intercept, 4, comma, 0.